Hey everyone, in this video I want to dive into managed disks, the different types available, the performance characteristics, how we use them with virtual machines, bursting, and how to monitor what's actually happening. As always, if this is useful, a like, subscribe, comment and share is appreciated, and hit that bell icon to get notified of new content and when I do live events. Now before we get started, I actually want to run a couple of commands that really set up a demo for later on. So I'm actually going to switch over to a remote machine. So this is a virtual machine running in Azure. And what I'm going to do initially is super quickly, I just want to run this command for 10 seconds. So I'm going to run it for 10 seconds. And it's just doing a performance test. And again, I'm going to come back to this later on and explain exactly what it's doing and why we care. But I just want to run it right now before I do anything else. And then what I'm going to do is once this 10 seconds has completed, and we can see there's kind of a bunch of output from this kind of execution, we're going to come back and look at that later on. But now in the background, while I'm talking and doing the rest of the presentation, I'm going to have it running for 2000 seconds. So about 33 minutes. So let's kick that off, and that can have some good fun in the background. So while that's running, let's get back to kind of the goals for this session. Now, in the days of old, before managed disks, we had the idea of unmanaged disks. And I could really think, well, what I created was a storage account. And remember that storage account has certain properties, a number of IOPS it supports, etc. And what I would then do is within that storage account, I would create a page blob. And then within the page blob, we would actually create our VHD file. So that's what was happening behind the scenes. Now, that individual disk would have a certain set of performance characteristics, like 500 IOPS per second. The storage account would have its own set of limits. And so I had to be super careful that I didn't put too many disks running at the same time on a storage account, or the storage account would actually become the throttle. And so this was solved with managed disks. So the idea now was, hey, we have this great managed disk construct that, hey, it has limits based on, for example, the type of managed disk I create. But because this became a first-party ARM service, it added things like, well, I had role-based access control. I could do things like snapshots. We had capabilities, for example, like images were now kind of a first-party service. It could kind of integrate with availability sets and availability zones to kind of spread things out in a managed way. And one of the big changes that did happen is in terms of paying for the service, what I pay for over here is always the provisioned size, so the provisioned capacity. Whereas in the unmanaged, if it was standard, I would pay for the used capacity. So there's a difference here. If I create kind of this managed disks and it's 100 gigabytes, I pay for 100 gigabytes. It doesn't matter if there's 1K or 100 gigabytes written to it, I pay for the provision size. And really what's happening with this managed disk is it's just doing an abstraction. This is still here, but it's abstracted for me. So I don't see the storage account, I just see this first-party service. Now, if we really dig around, if we're nosy, we can actually still see how there's a storage account behind here. If I jump actually over for a second, and we just look at a little bit of code, well, firstly, I could kind of look at all of my disks. I'm just doing a get AZ disk. I'm looking at the name, the resource group, the size in gigabytes, and then I'm actually using an expression to look at the SKU.name. I'm going to store that as disk type. So if I run that command, we can see I've got a number of different disks at the bottom here. I can see the resource group, I can see the size, and I can see the type. So that's what I see. But I can actually get a disk access, shared access signature. For example, I might want to use that for copy operations. So using this grant AZ disk access command here, I'm going to ask for a token. It's going to last 60 seconds, i.e. when you see this token, it's going to be useless to you. And I'm just doing it as a read token. But if I execute that, remember, this would be useful for maybe to copy a managed disk around, maybe copy into an empty managed disk, etc. But what I'm actually going to see once this comes back, because it's going off and actually granting this is a disconnected disk. This is a lonely premium disk. You can see from the disk name, prem disk lonely. It's not actually connected to anything. This will give me the shared access signature, and the shared access signature, well, that will actually show me the storage account name. So if I now go and look at disk SAS, well, you can see right here, there's the storage account name that's being used behind the scenes, md- kind of this random string, blob core windows.net. So we can actually see that there's still a storage account behind all of this. It's just abstracted away for us. So we like dealing with these managed disks. Now, if I think about a disk, there are different characteristics we have to think about. Now, it's very common when I think of a disk, I automatically would jump to, capacity. We might think of that in terms of kind of gigabytes, or we're actually going to use the term gibibytes. So you'll see in the Azure kind of documentation, it's always this G_ib. So that's gibi instead of giga. And really the difference in all of these things is, strictly speaking, a gigabyte is times 1,000, whereas a gibi is to the power of 1,024. And when you're talking about K, like kibibytes, mebibytes, gibibytes, tebibytes, pebibytes, as you get bigger, it actually does make a difference. And that's why you see this GIB and MIB and TIB. Maybe a little distraction, a little bit of fun for a second. If we fire up the calculator, and if we look at this, so if you think about what normally happens with, let's say, a gigabyte, or a terabyte actually is more fun, which would be kind of 1,000 to the power of 4. 1,000 times 1,000 times 1,000 times 1,000. So if we did 1,000 to the power of 4, that's the size of a terabyte. Now, if we think about a tebibyte, make sure I'm saying it right. So if we now do a tebibyte, which is 1,024 to the power of 4, well, it's actually, if you look at that size, it's nearly 10% bigger. So when I'm very small in the kilobyte range or the megabyte range, it doesn't make a big difference. As you start getting bigger and bigger, well, that difference does actually start to count. So that's why we see this GIB, it's a gibibyte, a tebibyte. They're showing you the true size because they're counting 1,024, not 1,000. Anyway, I digress a little bit. So we see capacity. So that's really, how much I can actually store. Now the next thing we generally would care about is IOPS. So this is kind of the input-output operations per second. Now you might also see throughput. Now they're both super important. So these are all about really the performance that I'm going to see. If you think of an operation is a particular something I'm doing, I've seen an analogy of buckets. If I had 4 buckets, I can fill a second. That would be kind of 4 operations a second. Well, the throughput depends on the size of the bucket. I can do 4 operations, but if it's a really big bucket, the throughput is going to be more for the same number of operations than if it's a very small bucket or a cup. So we think as the throughput is really based on the number of operations I'm performing and the size of the operation. So sometimes we care about the number of operations, maybe they're small operations. Sometimes we actually care more about the throughput. It maybe is a smaller number of operations, but they're very big. We're dealing with big amounts of data in every operation, maybe talking megabytes instead of kilobytes. So then the throughput actually becomes more important. So it really depends on what I'm doing. Now there are other characteristics. Am I doing read? Am I doing write? Am I doing random IOs? Am I doing sequential IOs? That will impact the performance. The other one is actually latency. Now latency we typically measure in kind of milliseconds. So that's the idea that, hey, I issue some operation from the compute resource. How long does it take to maybe get to the storage, get action by the resource, the storage, and then acknowledge back to me? Because obviously this latency does have an impact on that performance. So we have to kind of bear that in mind. So we understand there's kind of these different elements. Now before I can go and pick the managed disk, which we're going to get to, I really have to understand my workload. Now I have some workload. We have the OS disk, but our application shouldn't be running on the OS disk. It has data. They'll be on data disks. I need to understand the characteristics of that storage interaction. I need to understand kind of the average, and I'm really thinking about performance here. I need to know the amount of data. Obviously I have to have the capacity, but what's the average kind of IOPS? What's the average throughput? And then what are the peaks? What does it maybe spike up to? And when I think about those peaks, well, what is that peak? So what is kind of the value? What is the duration? So how long does that peak last? Is it during a startup of the machine and the peak lasts for a minute or 30 seconds? Or is it at a domain controller and I have a log-on storm for about 15 minutes? And then I have to understand the frequency. How often is it doing this peak? Because again, it comes into when we start to look at the disks, there's different characteristics. So for all of these workloads, to help start driving decisions, I need to know. I have to understand my workload. So before we start trying to pick disks or anything else, I have to have this good view of my workload. Hey, look, there's the average. Maybe my average is 100. I'm just talking about IOPS here for a second. But maybe it shoots up to 1,000. And it does that for maybe 5 minutes. And then it goes down again. And maybe it does this every 4 hours. It has that peak. You need to understand those characteristics because it's going to really come in when we start trying to pick the most optimal storage solution. Yes, I could go and pick a disk that does 1,000 all day long. Maybe I don't need to. Maybe there's other ways I can really optimize how I'm spending my money, how I actually pick what workload I'm actually doing. So with that said, we're going to talk about the different types of managed disks that are available in Azure. And we saw this kind of capacity, IOPS, and throughput. And there are different sizes in all of these different families. And what we're going to see for the most part is I can really think about, hey, we have this chart, and I can think about capacity on one axis, and then kind of IOPS and throughput on the other. Now, obviously, they're different values, but what we're going to basically see is as the capacity goes up, so too do the IOPS and the throughput. They're really kind of a linear progression for the most part. So when I'm thinking about picking what disk do I want, I may pick based on the amount of data I need to write, sure, but maybe not. Maybe it's more a case of, hey, I have these high IOPS or high throughput. And so really the capacity I pick is not because of the amount of data, it's because I need to get to a certain IOPS or throughput for my workload. So it's really super important to understand that. And we can see these. So if I jump over for a second, and we're going to cover these different types of disks. But if I just look for premium SSD, for example, we can see here, well, sure, look, there's different sizes. So we have this disk size in gigabytes, and it kind of goes up for the various disks. And what you'll notice is as the size goes up, so too does the provisioned IOPS per disk once we get past kind of that P6. so too does the throughput. So the bigger the disk, the better the performance, and it kind of goes linearly. We see it really, the standard SSD, we don't really see that same kind of thing on the lower levels, but when you start to get up to the really big sizes, then we see they start to actually give us more IOPS and throughput. And then the standard hard disk drive, once again, we only really start to see the performance get better as we get to the really big sizes of standard hard disk drive. But it shows if we want the higher performances, well then we have to kind of go and get those bigger disks to get that performance. So let's actually talk about the types of disk we have available to us. Now, the most basic one, and we'll kind of go in order, is the standard. So we have the standard HDD. And as the name really kind of suggests to you, so this is based on hard disk drive technology. So this is obviously kind of the lowest performance. So it's the lowest perf, but it's the cheapest. Oh, it's the old kind of adage, you get what you pay for. And what we'll see is as we kind of go up through the different types, the performance will go up and the cost will go up. Now, a key point here is the performance that we get is not guaranteed. I.e., what it shows you is a maximum. It says this is the maximum you will see, but it's not provisional. I may not always see that number. And then from a latency perspective, the numbers they typically give is kind of a 10 millisecond latency for a write, 20 milliseconds for a read. So we get these different numbers actually for our workloads. So we would really say this is kind of non-critical. I'm playing around. I need some disks. I don't care about performance. I don't care about consistent performance. I really want it kind of as cheap as possible. And we can kind of see that. So if we go back to the documentation, we look at the standard hard disk drive. If we look at its metrics, notice the word it uses, up to 500, up to 60 megabytes per second. So it's really important to understand that word. It's an up to, not a provisioned. And here we can see it talks about those latencies. Write latencies under 10 milliseconds, read latencies under 20 milliseconds for most operations. Again, this isn't kind of a guaranteed, but that's what we're really going to expect for the most part. Okay, so then we get to standard SSD. So now I think, okay, so now we have standard SSD. Now obviously here we're going to see kind of higher perf. This is just going to continue to go up, but obviously it's going to cost a bit more. So this cheapest is going to get, it's a bit more expensive. But once again, the perf is not guaranteed. Once again, we're going to see that kind of, hey, up to statement. Now what we do get is this nice free credit-based bursting. So we get this non-guaranteed performance, but we actually do have the ability to go above that within this kind of bucket of burst capability. Now I'm going to talk a lot more about this at the end. That's why I'm kind of run that command to try and get some kind of things running in the background. But we do actually get this credit-based system where, hey, I can kind of, like my cell phone, if I don't use all the minutes, I can carry them over and then use them in this kind of bigger bang way. Now for the latency here, what we're really talking about is single digit millisecond. So it should be less than the 10. It's going to be better than the standard hard disk drive. So I'm going to get better latency. Workloads, again, we're really talking about low storage requirements. Probably maybe little basic web servers that aren't doing a lot potentially. But still, I'm not going to use it if I ever need kind of some guaranteed type performance. I'm just not going to get it when I'm dealing with the standard SSD. And once again, if we bring it over to the browser, once again, we can kind of see that. We can see it's, hey, compared to standard hard disk drives, the standard SSDs, looking at this statement here, better availability, etc., better latency. But again, the key word we really care about looking is this statement around up to. It is not provisioned again. But it does say, hey, look at this max burst. I get this bursting up to 30 minutes if it's kind of 1 terabyte or smaller. And again, I'm going to go into detail on that. Okay. So now we get into premium. So premium SSD is really where a lot of companies will start when I think about production workloads. So again, the performance is just going to keep getting better. So again, higher perf again over kind of here. And again, the price is kind of going up. Now, one difference here today for the premium, remember we talked about, I basically pay for the capacity and I get a certain performance that aligns with that capacity. One of the things they've actually done with premium is that still happens. So when I pick the SKU of my disk, I pick kind of the capacity SKU. So I pick a certain size disk and I get a certain set of performance. But it's actually possible to also specify a different performance SKU for my disk, a higher one. And the idea here is, let's say I pick a disk for a size I want. I need 12 gigabytes, for example. But maybe I have a fairly long duration where I need higher performance. Maybe I'm doing some big import. It's going to take 2 days. Well, I can actually increase the performance of the disk. And then once that job is finished, I can bring it back down again. Now, the whole point of this is I can't just constantly be moving this back and forth, back and forth, back and forth. There is the idea that I can only do this. I think I can lower it every 12 hours. I can downgrade that performance tier. But this is really useful because I don't want to increase the size of the disk. If I increase the size of the disk, I can't shrink it again. So this is, hey, look, normally this capacity is absolutely fine. The performance is fine. But I'm doing this big job where I need a higher performance for a limited amount of time. I can separately raise the performance of the disk without actually having to make it bigger, because then I'd be stuck. I couldn't shrink it again. So if we jump over to the portal for a second, and just to kind of see this in action. Now, ordinarily in GA, to do this, I actually have to disconnect the disk. So it has to be either disconnected from the VM or deallocate the VM. But in preview, it actually lets me do this dynamically. So this is a premium SSD. You can see that over here, premium SSD. And if I go to size and performance, what's kind of special here is the primary thing you pick is the disk SKU. So mine is a 4 gigabyte, so I get 120 IOPS, 25 megabytes per second. But if I scroll down, I can actually pick a different performance tier. So I could leave the disk at that size, but maybe I need 5,000 IOPS and 200 megabytes for the next 24 hours. So I can actually do that. I can separately change the performance without having to resize the disk. Now, what am I going to pay for? I'm going to pay for whichever one is higher, which is always going to be the performance SKU. I can't make it smaller than the disk. So for the period of time where I increase the performance SKU, I'll be paying for a P30, even though the capacity of the disk has not changed. But then once I've finished, hey, I would change it back down again. I think there's a period of time it takes to actually take effect. I think it's within an hour, or maybe it's quicker than that. But I can actually go and change that performance. So that's kind of something unique actually about that disk. So let's go back over again. So I have these separate capacity and performance. Now, we are now getting into provisioned performance. It is not up to. If I look at the words on the site for this disk, what it now says is provisioned IOPS per disk, provisioned throughput per disk. That is super important. This is basically now guaranteeing that is actually the performance I will get. So if I need a guaranteed performance consistently, well, that's where I get into premium SSD world. Also, so what's interesting, I get bursting, but there's actually two types. Yes, I get the credit based. So once again, I get that kind of bucket for up to 30 minutes. And once again, that's free. But there is also an on-demand option. And that costs me money. That costs me money to turn it on. That costs me money when I actually use it. So this is designed for longer bursting. So maybe those little buckets, that 30 minutes is not enough. I need to burst for longer. So with on demand, I can turn this feature on, and then whatever additional performance I use, I'll get billed for. Now the way they're actually doing this is this credit based, I'm going to use if it's less than a P30 disk, which I think is 512 gigabytes. This is for P30 and above. So if we look at the site for a second, so here less than the P30 is a P20, and we can see, yes, this P20 has this idea of a max burst duration. But then the P30 and above does not have that option, but instead it does have this kind of on-demand bursting. So you can see it talks about here the different burst options. So this automated credit system, and we have this max option. And this is always turned on by default. But then the on-demand bursting, if we actually jump over to this page, so this is about managed disk pricing, and looking at premium disks. And here we said the bursting, so for a P30 and larger, so you turn on a monthly enablement fee to enable the bursting, then a burst transaction fee of half a penny per 10,000 IOs for additional IOPS. So you then actually go and pay if you want to use that. But again, the P20 and below, you get that free kind of credit bucket just like anything else. And the documentation, and I'll add this in the description, talks about how you actually enable that on-demand bursting through PowerShell, CLI, etc. So I will have all of that kind of in there. So as we can kind of see, for the premium SSD, we have a lot of options here. So we get the provision performance. I can separately change the performance SKU, but I also, if it's less than a P30, so 512 gig or smaller, I get this free 30-minute bucket, or I can do on-demand bursting. And you might say, well, which one do I do? And it's really about how long is this going to run for. If I need this higher performance, but it's still fairly limited in time, I could do the on-demand bursting. But if it consistently needs a higher performance than what I get with a capacity, it will be cheaper to just change the performance SKU. That will actually give me a better overall performance. Latency is that kind of single digit. Millisecond. And so really what we're thinking about here is this is kind of production. These are production where I need that kind of guaranteed consistency really of my performance. And then finally, we get to Ultra SSD. So this is the highest performance. And this is actually very unique. I have SKUs in really all of the other things. And these are all based around capacity. This has capacity first, but also performance. What this has is I have capacity, I have IOPS, and I have throughput. I have 3 dials, and I pay for each of kind of how I set the various dials. The IOPS and the throughput, I can actually change dynamically. I don't have any L's in that, dynamically, dynamic. So I could think about, hey, I have the workload, and hey, I have a busy time overnight. Let's increase the IOPS and the throughput, and I'll pay more. And then that job is finished. Let's lower the IOPS and the throughput again to optimize my spend. And we see this in the pricing page. So if we actually go and look at the pricing, and let's find Ultra Disk, probably all the way at the bottom. Here it shows me an IOPS range, but as soon as I essentially hit the 1 terabyte, I can go up to 160,000 IOPS and 2 gigabytes per second. And notice how it's charging me. I pay for the capacity, a certain amount of money. I pay for the provisioned IOPS, a certain amount of money. And I pay for the provisioned throughput, a certain amount of money. And if I have a VM configured to use Ultra and I don't connect an Ultra to it, there's a certain charge for that as well. So I have the dials that I can really change at any time. In my little sample code file, actually, let's jump over for a second to my file. I don't know what it's doing anymore. It's doing something very strange. Let's go over here. This is an example of changing it dynamically. So this disk could be connected to a VM. I create a new config, and I have this new AZ disk update config where I set a new IOPS value. Then I update the disk. So this disk could be connected to a running VM, and I'm just dynamically changing the IOPS actually for that virtual machine. So it's really powerful how I can actually use this. So that's kind of the Ultra disk. Now, in terms of, once again, it's provision performance. So it's kind of guaranteed. It does not have any bursting. So there's no bursting, but you could kind of argue it doesn't need it because I would just dynamically change the IOPS and throughput as needed. So who cares? Latency, so this is where it gets kind of crazy. Latency is sub-millisecond. So we're talking less than 1 millisecond. So in terms of use cases, this is going to be kind of databases. So I have databases, super high storage perf. I mean, that's really where I'm going to be using these. So we have these different types of disk, and kind of to summarize the idea, obviously as you go that way, come on, the perf gets better and the cost gets higher. So that kind of summarize how those work. In terms of just a few other little features, I guess I should mention, all of these are LRS. So they're all locally redundant storage. So there's 3 copies of all of the kind of blocks you write. Standard SSD and premium SSD also support ZRS, where I actually have, there's still 3 copies of the data, but they're spread over availability zones. Another feature that may be of interest potentially is both the premium SSD and Ultra SSD can be shared. I can actually connect them to multiple virtual machines to have them actually come over as looks like a shared disk. So maybe I have a cluster or something else. It would look like I support SCSI persistent reservations, for example. I can actually use those as shared disks. So those are essentially my options. I have these are the types of disk, and you can kind of see, yes, performance goes up, cost goes up. I get some nice bursting capabilities with the Ultra. I get this kind of dynamic capability. Latency improves as we go down. So I'm going to pick based on my workload. And that's really kind of the key point on these things. When I change the Ultra, there is a delay when I would actually make that change. I could do it via a function, a logic app, I could schedule it, I could trigger it. It can actually take up to an hour. It shouldn't do, but it could do. And I think I can resize 4 times every 24 hours. One other comment before we start looking at some of the bursting things. We talked about kind of the capacity of the disk. When I create a managed disk, I pick a size. Now let's say I pick the disk of 6 gigabytes. Well, there isn't a 6 gigabyte premium SSD. So what it will actually do is it will, from a billing perspective, I'll pay for the next size up. So if I look at all of the disks that are available for a second, and let's go back and look at premium, for example. So if I create a 6 gigabyte premium managed disk, well, it's going to bill me for an 8 gigabyte, a P2. So just realize there aren't any kind of in-betweens of this. If I create a 6 gigabyte disk, I'm going to get charged for an 8 gigabyte. I will get the performance of an 8 gigabyte as well. So it's really going to work that way. So if I think about, okay, I create a 6 gigabyte, what I'm actually going to get billed for is kind of the next one up. So in this case, it would be a P2. So that's how the billing would work, which is obviously 8 gigabytes. I can resize disks. So I have to either disconnect it or deallocate the VM it's connected to. So I can increase the size of a managed disk. So I can make them bigger. This might be very common that when I create a virtual machine, often I'll create the virtual machine from an image. Well, that image is a certain size. The disk that gets copied will be the same size. Maybe I need it bigger though. So I can increase it. So increasing, great, I can do that. I cannot decrease. I cannot make a disk smaller. I would basically have to create a new disk and copy the content over. So just keep that in mind. And that's why Premium lets you have a different performance tier. Because, hey, maybe I need the better performance, but I need it for only a short amount of time. If I resize the disk, I would be stuck because I could never shrink it again. By having that separation of the performance and the capacity, hey, I can kind of solve that problem. Remember, if I make a disk bigger, that's making the disk bigger in Azure. Within the OS that's using that, I would have to go and increase the volume size to use that new space or create a new volume on the space that's left at the end. Speaking of which, this is all about the disk. Great. Disks have all these kind of attributes, this performance. But most likely, I'm connecting this to a virtual machine. Now, that VM itself has attributes. Now, this VM could just be a regular virtual machine. It could be part of a virtual machine scale set. It could be part of an AKS worker node. It could be running a managed database. It doesn't really matter. And the VM has attributes like, hey, number of virtual CPUs, amount of memory. But we're really focused on the storage side. So I think about, well, it has a number of disks I can connect to it. And then it has an IOPS. It has a throughput limit as well. So I think about, well, okay, I connect obviously an OS disk, which that OS disk, remember, has a certain number of IOPS and throughput. And maybe I connect data 1 and data 2. Each of those has an IOPS and a throughput. Maybe they support burst. Depends on the type of disk. The VM actually, some VMs actually have burst as well. I think the LSV2, the DSV3 and the ESV3, they support bursting. And that might change over time, so make sure you actually go and check, hey, what supports burst? But this is kind of super important. And also there's temporary disks. So there's kind of a temp disk over here that has certain characteristics. Some of them optionally, in fact, even the temp disk is optional now. Some of them have like NVMe, ephemeral, like locally attached storage, which has phenomenal IOPS and throughput, where I need local performance. There's also network, and that's kind of important to understand because network is really all based around a certain amount of kind of megabytes per second that it supports. And you care about that because things like SMB, NFS, even kind of iSCSI go over the network of the virtual machine. It's not using its storage characteristics. So if I actually go and look at a virtual machine, let's look at the DSV3, what we actually see is we can see those numbers. So yeah, I see CPU and memory, blah, blah, blah. I see temp storage performance, so that's cached. I see burst on the temporary storage, but then I actually see uncached disk throughput, IOPS per second, what it can do. Now this actually supports bursting for its storage, so I actually see a burst number. So I see that. It tells me how many data disks it actually supports being connected. And then it tells me the expected network bandwidth. So we get those characteristics as well. Now note, to use a premium SSD, I have to use the S variant of a virtual machine, i.e. the DS, the ES. Those are required to use a premium. If I look at the non-S variant, you'll notice it doesn't actually have data disk IOPS and throughput. Because really it's just based on, well, how many standard disks could I connect to? And you can think about what's kind of provisioned for the VM behind the scenes is based on a 500 IOPS disk. So hey, if it supports 4 disks, it's kind of 4 times 500, so 2000 IOPS. That's not a limit, because some of the standard hard disk drives can actually go higher. The standard SSDs can go higher than 500 per disk. So it may actually be able to achieve those at higher numbers, but it's not really provisioned for that. So whether you can actually hit higher numbers, there's no guarantee of that. So that's why we don't see those numbers for the non-S variants. There's no kind of higher provision other than 500 IOPS per data disk. That's really what it's based on for those disks. So why this is important to understand? The disks have a certain performance. The VM has a certain performance. So there's no good just throwing a ton of high performance disks at the VM if these numbers are essentially bigger than what the VM can handle. You have to understand both of those. Otherwise, you'll get into this situation where the VM will I/O cap you, or throughput. I'm focusing on IOPS, throughput will be the same. So if I need a certain performance going through my solution, I have to make sure the disks meet those numbers in terms of IOPS and throughput, but I also have to make sure the VM meets those in terms of IOPS and throughput. And just like disks, generally the IOPS and throughput will go up the bigger the virtual machine. Now there are different types of VM. There are some that are storage optimized, there are some that are compute, memory, GPUs. So you want to look at the different families of virtual machine. I'd want to understand what are the overall characteristics. How many CPUs do I need? How much memory? How much network? What is the IOPS and throughput I need? And again, what is that kind of bursting that may happen? Because maybe the bursting of the VM might meet what I need. But what you don't want to do is get into a situation where maybe the disks are just really, really powerful, but the VM's always going to cap you. You're just wasting money on the performance of these disks. I want them pretty balanced. One will generally be bigger than the other a little bit. That doesn't matter, that's fine. I just want to make sure I can meet my actual requirements. So make sure you consider the VM as well. I really don't just want to get capped on the virtual machine. That would be kind of a sad day. So let's talk about that bucket. So remember I said for the standard SSD and the premium SSD, we get this free credit-based bursting. And it's kind of up to 30 minutes. We saw that when we looked at the documentation of the disks. So if we go back and actually look at the disks for a second, if I actually look, so what's this? Okay, so this is the standard, so this is the premium. So remember, premium said, hey look, we can burst up to a higher value, even though my provision is 120 IOPS, tiny, all the way up to kind of 2300, they can all actually burst up to 3500 IOPS. They can all burst up to 170 megabytes per second, up to 30 minutes. Now, even the standard SSD also, hey, we have the standard IOPS of 500, standard throughput, and they can burst to slightly higher IOPS, but the throughput is fairly significantly higher. So they have a burst, and once again, that is 30 minutes as well. So how is this working? So the whole idea of this really fundamentally is the idea that I have a bucket. And this is kind of my burst bucket. And it actually starts off full of kind of 30 minutes worth of bursting. So that's the idea. Now, I have my workload. So I have my workload running. And let's just say this is my disk. This is one of my disks. Now that disk has its expected kind of performance line. And then I have what I'm actually doing. So let's say I'm hovering here. If I go above that line, all of this here is coming out. So I'm coming out of the bucket. So my line would be dropping. I'm using that up. When I go below my provisioned amount, that amount is going in. It's refilling the bucket. So it really is like minutes on a phone. If I use less, hey, I can kind of carry them over to next month and do more talking. That's really what's happening. Now, there is an upper line. So we have kind of that max burst IOPS. Remember, this was kind of my provisioned or up to. So they're kind of the numbers that we're seeing. So we can think about, hey, when we go above our line, if there's any burst left in our bucket, I can go higher. When I go below my provisioned, I'm going to start filling it up. Now, obviously, the bigger the disk, the more filling I can do. I.e., if I'm a really small disk, well, this number is 120. So when I drop to idle, I'm still only adding 120 IOPS per second. Whereas if I'm a much bigger disk, maybe I'm adding 2300 IOPS when I'm idle. So you kind of get the idea that it's based on the size of the disk is how much I can fill my bucket, so how much I can then burst to. And we see that when we look at the disks, remember. So if I look here at my kind of little P1, my provisioned IOPS is 120. So if I'm idling, I can fill the bucket at 120 IOPS per second. Whereas if I was this nice P20 and I'm idling, I can be adding 2300 IOPS per second. Now they can all burst to the same number, but what this would essentially mean is if I emptied the bucket, to refill it for my poor little P1 is going to take a long time. Whereas my P20 is going to start refilling that bucket for the 30-minute duration a lot quicker. I'll probably be able to refill the bucket, what's that, in like 40 minutes. Whereas my poor little 120 trying to fill a bucket to 3500 for 30 minutes, I know that might take days. My math is not that good. But you see the idea, it would obviously take longer to refill the bucket. And what I really wanted to do, again, I'm saying IOPS throughput is exactly the same. We have that same kind of bucket. I want to show you this. I want to actually show you this bursting. So if we jump over for a second, what I have is a virtual machine. Now on this virtual machine, I have, you can kind of see over here, 2 disks. Now they are little disks, little 4 gigabytes. So they are these puny little P1, 120 IOPS, 25 megabytes per second. So they are very small. Now remember, I can add and remove disks dynamically, data disks. I could just add a disk while the VM is running. I don't have to shut it down to add and remove disks. But this disk, remember this little 4 gigabyte disk over here, well, it actually can burst to 3500 IOPS. Now I'm running this on my DSV3, and it actually has an uncached IOPS without bursting of 3200. So keep those numbers in mind. So let's look over here for a second. So that actually finished. So I ran for 30 minutes. Now what I want to show is let's scroll up to the first test I did for 10 minutes. So let's go all the way up to the top. And what I'm interested really is this IOPS per second here. And what I can see from that is, look at that number at the bottom, 3276.42. So I was actually doing 3,276 IOPS on that little weedy disk that should only let me do 120 because I'm bursting. That's exactly what I can see because I ran that for 10 seconds. And then you saw I ran it again for 33 minutes. Now we'll see something different. The IOPS is still pretty high, but it's a bit lower because I would have exhausted my bucket. And that's kind of what I was trying to show. Now if I rerun it right now for 10 seconds, let's see what we get. So I'm going to run it again just for 10 seconds. Now I think at this point the bucket might have started to refill, but it will refill pretty slowly. I'm not expecting to see that 3200. The 10 seconds might be too short. It may have actually done something because I've been talking for so long. But let's see what we actually get now. So if we go up, oh, okay, I'm still seeing pretty good IOPS because the bucket would have refilled for that limited amount of time. But let's actually look at this then. So obviously the bucket refilled because I'm talking way, way longer than I thought I was, as always. Let's look at that virtual machine for a second. And what I want to do is show you some metrics. What we're actually going to do right now is I'm going to jump over and we are going to go to our metrics and we're going to look at a number of different metrics. So the first interesting metric is data disk target IOPS. And we can see 120. That's my target. Yep, that's what we kind of expected. Now I'm going to add another metric, which is my data disk max burst IOPS. Also, there's that 3.5K. Then we're going to add another metric. Now, I was doing all read operations. So I'm going to look actually at data read operations per second. And I want the maximum. So there we can actually see, hey, I was doing, and let's actually just look. I don't want to look for 24 hours. Though you can see I ran this test before. But I'm actually going to run it just for the last hour. So you can see, there was my test. Now notice, right at the end, see this little tiny bit at the end? It dropped. And it dropped because I would have exhausted my bucket at this point. This was 30 minutes, and my bucket would have got exhausted. Now we can actually see the bucket. So if I add another chart, and what I can actually see is my data disk burst IO credits percentage. And again, I want to look at the maximum. And again, we're looking at the last hour. So you can kind of see, hey, I was at 0% of my bucket. And then I steadily just used it all. Using it, and I maxed it out. And at the point I maxed it out, it was kind of actually put it over here. We can see the performance started to drop. So we see here, my performance dropped. And then you'll see it actually starts to go up again. So we can see it refilling the bucket. If I change my timing to 24 hours, because I did run the test yesterday. So I ran the test yesterday, and you can see, hey, it maxed out. And again, the performance dropped. And then over the course of basically 14 hours, it was filling the bucket back up because the disk was idle. And now I'm using 0% of my bucket. And then I use my bucket up again. And now it's going to start to refill again. So that's how I can actually see what the bucket is actually doing. So it's actually really cool. Now the other thing I wanted to actually show you is when I'm looking at metrics. Now I had 2 data disks, remember. Let's look at a new chart for a second. And I'm just going to add in data disk. Let's just look at the read operations per second. And I'll look at the max again. Now I had 2 data disks. Now I'm looking at this, it's like, well, I had 2 of them. I want to see the individual disks. I can apply splitting. When I apply splitting to this button right here, I can split based on the LUN. Check. And now I see both my disks. So I can see the individual numbers when I have individual disks. So you can see here, well, yeah, okay, LUN 0 is the one actually doing all the work. LUN 1 is really not doing anything. So you can go and get all of the different data. So definitely take some time. And again, I'm showing IOPS, but there are ones for throughput. There's ones for the OS. There's a phenomenal amount of data available to me. Now, one thing when you look at these, remember, sometimes I have to look inside the guest OS, like capacity. Well, capacity is actually creating volumes and data inside the disk. Azure doesn't really know about that. That's something the OS knows about. So I'd look at the guest properties to actually see the capacity used of a disk. So sometimes I have to go to different places. But that was it. I mean, that's kind of everything I wanted to cover. Hopefully it makes sense. Hopefully you kind of get the idea of, hey, there's different characteristics of the disks. It's important I understand my workload, the average, the peaks. What does it peak to? How long does it peak for? How often does it peak? Because maybe I can use the burst capabilities of the disks to handle that. Maybe I can't. In which case, maybe I use some of those changing the performance skew. Maybe I use on-demand bursting. If it's ultra, I could automate when it increases and decreases the IOPS and throughput to match when those workload or batch jobs run. We looked at the different types of disks. Obviously, we get higher performance, we get higher cost, we get lower latencies as we go up, and maybe get some more flexibility in kind of the feature sets. Don't forget about the VM. The VM has its limits as well. Make sure you're considering those when you plan the all-up solution. And the bucket. That bucket for those data disks, for the standard SSD and the premium SSD, super powerful. 30 minutes. Realize, obviously, the more powerful the disk, when it's idling, you refill the bucket quicker. So that was it. I really hope this was useful. Please subscribe if this is. It's really appreciated. Until next time, take care.